Yeah. So, howdy guys, we're group two. Logan, Andrew, and me. And this is what we came up with. So,
So we started with the whole thermodynamic cooling system that we talked about earlier, in conjunction with what Logan had said before about, or like explained before about aquaponics. So assuming that we're going to have aquaponics in like our system, we could run the pipes that we need to cool through the water that's already there for the fish pond, and have the heat pump as well to heat other things we need. So yeah, the pipes just run through the water, and then get the cold water comes out as well for other things. And then the heat pump is over on that side that reuses that heat that gets emitted into the water from the pipes.
and so along with the wastewater and all the material stuff, we want to utilize the microbial fuel cells because we don't want that. So we want to get like multiple solutions to the same problem, right? So aside from the micro fuel cells, we also wanted to use some of the mushrooms so that way we can use something out of it and like have something to produce with the waste, not just convert it back into the single cycle, but actually have something to give and like expand on.
So this was a visualization just kind of sketched up on the iPad. I know it looks pretty primitive. So basically we started off with the basic principles shown in the first slide, which showed the transition of hot water being cooled through pipes, and then transported back into the housing as a water coolant system. And we decided that that could be combined with hydroponics. So those sterilized fish that I mentioned, you would put those in the same environment. And the reason why that would work is because these are actually pipes. You're not like mixing the water in, like the piping is going through and the hot water is being cooled by the fish, by the water with the fish in it, and it's traveling back out. And so the fish will be producing things that can be used as manure for plants. And you're also going to be taking waste from housing and waste from industrial sites that can be recomposted into fertilizer. And that's going to be pumped down alongside excrements from the fish into the bioreactor. And so all that's being pumped down into the bioreactor. And there's also going to be mycelium down below. And so what I decided so it might be difficult to find a hydrological mushroom. And so I decided that that'd be better if you had a cave system where the mushrooms can still be underwater, but you just have a little separation zone. So the water can still access the mycelium, which is, if you didn't know, that's the roots of the mushroom. So the mushrooms can still live, but they're blocked off. So there's actually like an air pocket here. So the mycelium can still be accessed by the water here in the bioreactor. And obviously mushrooms are going to die if they don't have access to CO2. And so CO2 is also being pumped in a small amount to the mushrooms in order to sustain that system. So once the water is purified in a bioreactor, it's going to be pumped back up to the top of this system, and it's going to come down as rain onto this like water tree sort of system right here. And so I theorized this could also double as like a recreational center because this is purified water. This is all clean water, clean plants. There's no human waste or anything happening right here. So this can be a recreational area, a place to like see while you're having lunch. So it doubles in a humanitarian aspect. And so the mycelium, this can serve as a insulator, and it also can serve as like a brick. So not only can it serve to aid in like water purification process, but it also can be used as like a natural insulator in brick form. And so there's a non-organic film here because obviously a tree can't sustain itself sitting on a big pool of water. So the organic film is supposed to serve to where the water can pass through, but you're not going to have an issue where all like the unnecessary excrements from the fish would prohibit the organic area from surviving. And so that's the whole system right there. And additionally, one more thing that I forgot to mention. So this water that's coming from the purified system down here at the top, we are looking at CPU coolers, and the way they work is through like radial like fins that air passes through to cool them down. And so there's like basically fins right here. And the way it would work is like a slanted fin with holes permeating it. And so the water could flow down here, kind of like a waterfall. And so you could have heat generated by industrial systems and by humans. And that could be, all that heat would be radiated right here, like maybe through a pipe or just through natural airflow. And the water would serve to cool it down. So you've got warmer water pouring down over here, but that shouldn't negatively impact the plants. But the water is going to be doubling as coolant for the human systems, and it also serves to reinforce the natural habitat. So that's it.
Yeah, I didn't quite get why you're saying that you need to have like an enclosed space for the mycelium when you can have it, outside, being on the water.
So the mycelium down here actually serves to purify the water. The mycelium right here doesn't really do any purification. It's just like a construction material to demonstrate that the mycelium serves double purposes.
But at the bottom, the reason it's in enclosed space is because it's the waste to grow to its growing.
Yeah, so I know he said mycelium, but this is like the actual mushroom. The mycelium is like the byproduct, right? So the way it works is you keep adding, you don't let so the mycelium starts first for the mushroom, and you don't let it turn into a mushroom, you just keep it in that state. And then once you have enough material, you can cut it off, like sterilize it so it doesn't grow anymore. And then that's when it turns into a brick and use it somewhere else. But you want to keep it alive, so you don't want to run out of the mushroom, right? So that's what we have like a designated growing spot for it.
Are they growing out of poops? Is that what it is? That's why we need to hide it? Stick it down
Yeah. Anything, really.
there. So it's probably the odor management, right? You don't want the odor of that to be among the residential area. Is that
Well,
right?
yeah,
You
and
have to
then
put it
that-
down there?
Yeah, and then that, you don't want it to work with the fish and.
Yeah.
like, on the bottom.
And so the problem is that a lot of mushrooms can't like survive underwater. I've never heard of like a aquatic mushroom before. And I'm pretty sure the candidates that were chosen to serve as mushrooms aren't aquatic. And so it made sense to me to have like a pocket here with like a cave system. So like the actual cave, like it curves down and the water can actually pass through and like lap up against the soil where the mushrooms are. And so this creates a pocket right here to where CO2 can be pumped down for the mycelium.
I want to explore the separation toilet idea and have mushroom work with the solid waste, species and or.
Oh, it does.
Yeah, that
So
was-
this
and-
is
But then you
a
got the water coming in too.
uh-huh.
Why does the water need to go in?
In truth, I don't really understand the whole process of the bioreactive systems very well, but I imagine that there would be some loose like fluid that's being purified to go through the process. So I figured that the mycelium can serve as like sort of as part of like the purification process.
Okay, so I guess in that case, maybe you want to explore more decentralized type of solution because I think the reactor is still a mechanical solution. So maybe looking into breaking this down into 2 different microbial fuel cell settings that will target urine and solid waste separately. And you can still grow mushroom in both settings. For the solid waste setting, mushroom just grow out of the solid waste, and the urine you might need to have growing medium and you use the urine as sort of irrigation source, like liquid fertilizer for the mushroom.
So do you think that the mushrooms, do they actually, would they better process solid or liquid waste?
For the mushrooms,
Mhm.
I think that both can work, just that you have to design it differently.
Yeah, I know specifically for, at least for the test studies that they were doing for the bricks, they specifically chose like sawdust and water and like some other, I think it was like phosphorus, food or something for the mushrooms. But I think that was all solid, at least for the most part.
Yeah, you can use coconut oil as the substrate and then just irrigate it with the urine. Maybe dilute the urine and so on. You know, the bioreactor is still a mechanical component you have to bring from Earth. So we're really trying to come up with a solution that does not require any payload to begin with. So if you use a landscape-based microbial fuel cell setup, you can create that landscape over time as you grow more plants that can be turned into biomass and healthy soil. And you can grow a landscape setting that would then be able to accommodate two different microbial fuel cells for either treating solid waste with urine while growing the mushrooms.
So is the bioreactor, like problematic in the space habitat? Is that-
Because it's gonna have to have weight, right? It's mechanical equipment. And for the entire city, just imagine how much weight you're adding to this business, right? Yeah.
Yeah.
Does that make sense to you?
Yeah,
Cool, but this whole closed loop idea is excellent, and I would say the pumping part, if you can, like what we talked about in the class, figure out how you preserve the hydraulic head so that you don't have to pump it down, pump it up. You know, what if you just treat it up there to begin with, and it comes down with gravity? So like thinking about a design that doesn't require pumping, or maybe use some of those mechanisms like Noria or windmill, whatever else you could do to pump without power. Yeah, cool, great.